What if I told you that the state of Ohio sits atop a buried, immense ghost river, older than the entire Ice Age? That it hides one of the world's most pristine fossil treasure beds just south of a major metropolitan area? And that it features an island chain where ancient glaciers carved massive grooves big enough for you to stand inside, all while a major continental divide runs straight through the city of Akron. This is 50 Ohio geography facts you never knew, and a bunch you'll never forget. 50. Lake Erie, shallow giant, big consequences. Lake Erie is the shallowest and warmest of the Great Lakes, averaging only about 62 feet deep. This shallow basin has profound consequences for the state. Because it's shallow, it warms up quickly in the summer and cools rapidly in the fall, making it volatile. It can turn from glassy calm to a dangerous storm-tossed sea in minutes. This characteristic also supercharges its ecology. The warm, nutrient-rich Western Basin is a global hotspot for algal blooms in late summer, while the same warm water, when exposed to cold winter air, fuels the infamous lake-effect snow that blankets the northeast shore. 49. The islands you didn't know Ohio had. Ohio is a freshwater coastal state, complete with a chain of beautiful, often busy islands. The main group includes the Bass Islands, South Bass, home to Put-in Bay, Middle Bass, and North Bass, along with Kelly's Island and several smaller inlets. These islands sit in a unique microclimate mellowed by the surrounding lake water, which moderates extreme temperatures. This geography made the islands historically famous for agriculture, particularly for growing grapes and producing wine. Today, they're popular tourist destinations, offering rich history and remarkable geology that you can literally walk upon. 48. Kelly's Island's Glacial Grooves, Scars from an Ice Highway. On Kelly's Island, you can visit one of the most stunning examples of Ice Age geology in the world, the Glacial Grooves. This massive rock trough was carved into the local Devonian limestone by the colossal weight of the Pleistocene ice sheet, which drags smaller stones and boulders across the bedrock. These grooves are considered the largest accessible glacial grooves in the world. When you stand inside these deep, polished scars, you're literally standing within a page of Earth's dramatic glacial history, seeing a textbook example of how the advancing Ice Age physically reshaped the entire northern half of Ohio. 47. Marblehead Lighthouse, a Great Lakes elder. Guarding the treacherous passage into Sandusky Bay and the tricky island channels beyond is the Marblehead Lighthouse. Established in 1822, it holds the distinction of being the oldest continuously operated lighthouse on the Great Lakes. It stands on a jagged outcrop of Silurian-age limestone ledges, which resisted the forces of glacial erosion that smoothed the rest of the coastline. The lighthouse's enduring presence highlights a critical geographic choke point, the interface between the vast, shallow open lake and the protected harbors essential for early commerce and shipping. 46. Cedar Point is a moving landform. The peninsula that hosts the famous Cedar Point amusement park isn't just a random stretch of land. It's a living lesson in coastal geography. The entire 7-mile peninsula is a massive sand spit, a landform built by the steady, relentless force of longshore drift, where waves and currents deposit sand as they move parallel to the shore. Over millennia, this process stretched the sandbar across the mouth of Sandusky Bay. The physics of the shoreline literally created the stable, though still dynamic, piece of land that made the entire concept of the roller coaster capital possible. 45. The Cuyahoga that caught fire, and why that's geography. The Cuyahoga River achieved global infamy in the 20th century because of its industrial fires, the most famous being the 1969 blaze. This pollution was partly a result of the river's unique geography. Its lower section, which winds through Cleveland, is glacially carved and naturally sluggish, featuring tight, meandering urban bends where industrial waste and pollution would become concentrated and trapped. The subsequent cleanups and the creation of the Cuyahoga Valley National Park are a rebound story, turning a geographically vulnerable area into a protected natural treasure. 44. Cuyahoga Valley National Park, Canal, River, and Ravines. America's Cuyahoga Valley National Park is a unique fusion of human and natural history. The park's geography is dominated by the Cuyahoga River and the adjacent historic Ohio and Erie Canal. The flat path of the towpath exists because it follows the naturally level glacial terraces carved by meltwater from the retreating ice sheet. Meanwhile, the dramatic, steep side valleys and gorges, which feature waterfalls like Brandywine Falls, are the result of water aggressively cutting through the soft shale layers of the Appalachian Plateau, displaying two distinct types of erosion at work. 43. An invisible continental divide runs through Akron. The city of Akron sits on a fascinating and critical geographic feature, the St. Lawrence Continental Divide. This divide is a subtle, invisible hump in the landscape, but its impact is enormous. Water that falls north of this line, such as in Summit Lake, flows through the Cuyahoga to Lake Erie and eventually into the St. Lawrence River and the Atlantic Ocean. Water that falls south flows into the Tuscarawas, then the Ohio River, and finally into the Gulf of Mexico via the Mississippi. This low-elevation divide is why the Ohio and Erie Canal had to climb to Summit Lake. It was historically a critical portage country that became an industrial artery. 42. The ancient Teays Ghost River. Hidden deep beneath the glaciated plains of Ohio is the ghost of a giant waterway, the Teays River. Before the glaciers advanced, the Teays was an enormous river that flowed from the Appalachian Mountains across Ohio and into the Midwest, potentially rivaling the size of the modern Ohio River. The approaching ice dammed, buried, and permanently diverted the river, filling its valley with glacial drift. Today, this vast buried valley is a colossal, unseen asset, the Buried Valley Aquifer, which still feeds major cities and industries across Ohio with pure, naturally filtered Ice Age water. 41. Blackhand sandstone carved into Hocking Hills. The breathtaking landscapes of Hocking Hills, home to iconic features like Old Man's Cave, Ash Cave, and Cedar Falls, are the result of a geological capstone known as Blackhand sandstone. This hard, erosion-resistant layer sits atop softer, more easily eroded shale and siltstone. Water seepage, the powerful freezing-thaw cycle, and surface runoff work tirelessly to hollow out the softer rock beneath the sandstone cap, creating the famous massive rock shelters, waterfalls, and deep ravines. This unique formation gives the Hocking Hills the rugged look of the Appalachians, seemingly dropped right into the middle of Ohio. 40. Wayne National Forest, Ohio's only national forest. Sprawling across the unglaciated Appalachian Plateau in southeastern Ohio is Wayne National Forest, the state's sole national forest. Unlike the glaciated plains, this region is a chaotic, rugged quilt of steep ridges and deep hollows. The forest is characterized by oak-hickory uplands that contrast sharply with the cool, moist hemlock ravines found on the north-facing slopes. This area maintains the classic, deeply folded, dendritic drainage patterns of Appalachia, showcasing the state's significant topographical swing from prairie flat to mountain folded. 39. Little Smokies on the Ohio River. The Shawnee State Forest, situated near Portsmouth in the unglaciated corner of the state, has earned the nickname Ohio's Little Smokies. The area's rugged, deeply dissected topography, featuring high ridgetop overlooks and misty, heavily forested valleys, evokes the look and feel of the Great Smoky Mountains or the Blue Ridge. The steep slopes and thin, acidic soils here discouraged widespread farming, allowing the landscape to remain heavily wooded and protected, serving as proof that the state swings dramatically from the smooth, fertile till plains to the deep, dramatic folds of the Appalachians in just a few counties. 38. Campbell Hill, Modest Summit, Giant Story. Campbell Hill, located near Bellefontaine, is officially Ohio's high point, cresting at a modest 1,550 feet above sea level. This small hill sits on the vast, smooth, and incredibly fertile glaciated till plain. The fact that the highest point is so low and so gentle tells the giant story of the Ice Age, how the glaciers acted as a massive planetary-scale plain, grinding down and smoothing the ancient mountains of the Midwest. This contrasts sharply with the rugged, higher peaks of the unglaciated southeast, a key geographical boundary defined by the furthest reach of the ice. 37. The flattest, richest farms came from ice. The vast, productive agricultural lands of western and northern Ohio are a direct gift from the glaciers. The receding ice sheets left behind thick deposits of glacial till, a rich, pulverized mix of soil, gravel, and rock, which created incredibly flat land and some of the world's most highly productive soils. The glaciers also left behind a drainage network that was later often straightened and organized by past ice margins. This geography is why massive, uninterrupted fields of corn and soy stretch seamlessly to the horizon in counties like Mercer, Auglaize, and Hancock. 36. Western Ohio's quiet karst country. Beneath the smooth, fertile fields of western Ohio lies a secret geography, karst country. This landscape is formed by the slow dissolution of underlying limestone and dolomite bedrock by acidic groundwater. This process creates hidden caves, fissures, and surface features like sinkholes and springs. A prime example is Cedar Bog, a national natural landmark which, despite its name, is technically a fen. It survives because ancient meltwater from the buried Teays Valley aquifer still seeps upward through the limey, fractured bedrock, creating a unique, cold, alkaline, and species-rich ecosystem. 35. Grand Lake St. Mary's, once the world's biggest man-made lake. Grand Lake St. Mary's, located in western Ohio, was built in the 1840s to serve as a massive feeder reservoir for the Miami and Erie Canal system. Upon its completion, it held the astonishing title of the largest man-made reservoir on Earth. Its existence is purely an act of human will, leveraging the geography of a flat till plain. Today, it serves primarily as recreation water, but its shallow, artificially impounded geography means it remains a critical case study in shallow lake nutrient management and the complexities of maintaining a vast, man-made ecosystem. 34. Buckeye Lake, a canal reservoir turned lake life. Similarly, Buckeye Lake, situated east of Columbus, began its life as another essential feeder for the Ohio and Erie Canal. The lake was formed within a shallow, natural basin, partially rimmed by an old glacial moraine, a ridge of debris left by the retreating ice. The moraine still dictates the lake's geography, shaping its shallow depth, numerous islands, and winding shoreline. Over time, the lake's purpose shifted entirely from commerce to recreation, leading to the development of beloved island and shoreline neighborhoods that embrace its unique, shallow water geography. 33. The Great Miami's Hidden Super Aquifer. Southwest Ohio's population and industry rely heavily on a vast, unseen geographic feature, the Buried Valley Aquifer along the Great Maumee River. This immense underground water source is stored in ancient gravels and sands deposited in the deep, pre-glacial valley of the Teays River. This geography allows the Dayton region to sustain a natural resource capable of supplying millions of gallons of naturally filtered groundwater per day. This super aquifer provides the Dayton area with a crucial advantage in water resource management, a direct inheritance from Ice Age geology. 32. Dayton's flood that redesigned rivers. The devastating 1913 flood of the Great Maumee River exposed a critical geographic vulnerability in Dayton and the surrounding region. The response to this disaster was a monumental feat of civil engineering and geography, the formation of the Miami Conservancy District. The district fundamentally redesigned the watershed, building a complex system of massive flood-retarding basins, levees, and channel improvements. This watershed-scale flood control plan became a national and international model for how to manage and tame a large river system in a geologically prone area. 31. Cincinnati sits on a fossil vault. The city of Cincinnati is perched directly atop the Cincinnati Arch, a massive gentle upward fold in the Earth's crust that exposes some of the planet's oldest surface rock. This fold has brought to the surface Ordovician limestones and shales that are incredibly packed with fossilized remains of ancient sea life, including trilobites, brachiopods, and bryozoans. This makes the region one of the world's premier fossil collecting regions, with specimens often found simply by splitting a rock in a stream bed or a city park, turning everyday landscapes into a window into the ancient past. 30. Roebling's River, the Ohio as an edge. The Ohio River defines the state's entire southern boundary. Geographically, it's far more than a line on a map. It's a profound climate and migration corridor. Its valley creates a noticeable climatological line, with the southern bank tilting towards subtropical conditions. The river's powerful meander has carved out a dramatic landscape, responsible for the deep valleys and the steep, defensible hills that rise abruptly behind the riverfront. This geography dictated the location of early settlements, and is the reason Cincinnati's riverfront and hillsides are so architecturally and physically dramatic. 29. The Emerald Necklace around Cleveland. Cleveland's metro parks are an essential feature of the city's geography, forming a system often called the Emerald Necklace. This system of preserved land is centered on the natural valleys and gorges carved by the region's major rivers, including the Rocky, the Chagrin, and the Cuyahoga. These rivers cut through the soft shales of the plateau to create steep cliffs, forest, and unexpected waterfalls, a rugged natural landscape that exists just minutes from the dense, flat downtown urban core, providing critical green space and flood control. 28. Cleveland's underground city of salt. A massive geological feature lies beneath Lake Erie, off the coast of Cleveland. Vast deposits of salt, the remnants of ancient seas that covered Ohio hundreds of millions of years ago. The Cleveland Salt Mine extends for miles beneath the lake, producing immense quantities of road salt. This mine is a subterranean world of excavated rooms and pillars of pure halite, a fascinating, almost monoscape-like geography that provides an essential commodity for the region's winter safety, directly linking the ancient past to modern infrastructure. 27. Toledo's Maumee. Shallow, mighty, messy. The Maumee River, which flows into Lake Erie at Toledo, drains a vast agriculturally intensive and flat farm basin that covers much of northwestern Ohio and parts of Indiana. This long, shallow river flows into the lake's extremely shallow western basin. The Maumee is the single largest source of fresh water, and thus the largest carrier of sediment and nutrient load into Lake Erie. This makes the river a key geographic and hydrological driver of the entire lake's ecology, particularly those severe, late summer algal blooms that plague the western end. 26. Oak openings, dunes in the woods. Just west of Toledo, the Oak Openings region presents one of Ohio's most unique geographic blends. This area is characterized by remnant sand dunes, swales or wet lowlands, and oak savanna, an ecosystem that feels like nowhere else in Ohio. Geologically, it's a vast deposit left behind by the shoreline of ancient Lake Warren, a massive proglacial lake from the Ice Age. The thin sandy soils and oak cover provide a fragile, critical habitat for rare species, including the endangered Karner blue butterfly, showcasing a landscape that has flipped from prairie to forest and is now being actively restored. 25. Lake Erie's seiches, bathtub slosh storms. Because Lake Erie is so shallow, it's uniquely susceptible to a phenomenon called a seiche. When strong, sustained winds blow across a long axis of the lake, they can literally pile the water up on one end, like blowing across a cup of coffee. When the wind stops, the water sloshes back, creating a standing wave. Water levels can jump several feet in just a few hours, momentarily beaching boats in one harbor while simultaneously causing flood conditions in a harbor on the opposite side of the lake. A dramatic display of hydraulic geography. 24. The Cuyahoga is two rivers in one. The Cuyahoga River's nickname, the Crooked River, is accurate, but its identity is split. Upstream in the hilly countryside, it behaves like a fast-moving, nimble upland stream. However, as it enters the flat, post-glacial plains of its downstream reach, it widens and slows into a deep, meandering industrial river, flowing through a vastly different landscape. This dramatic change in character is directly due to the changing underlying geology and gradient, from the rugged Appalachian foothills to the soft, flat, glaciated lake plain. 23. Summit County's perfect portage. The Continental Divide in Summit County, near Akron, is surprisingly low and gentle. For centuries, this low geographic point allowed Native Americans and early travelers to easily drag or portage their canoes between the headwaters of the Cuyahoga River, flowing north to the lake, and the Tuscarawas River, flowing south to the Ohio. The builders of the Ohio and Erie Canal later exploited the same geographic logic, choosing this route because it required the fewest and least intensive logs, proving that large-scale infrastructure often follows the subtle cues of ancient geography. 22. Holmes County Hills, America's Amish capital. Holmes County is the heart of America's largest Amish community. The topography of the region, located just on the edge of the unglaciated Appalachian Plateau, features fertile, rolling loess-covered hills, rich valleys, and numerous small watersheds. This landscape, with its narrow ridge roads and secluded valleys, naturally encourages a slower, more localized, and more agrarian pace of life. The geography of small defensible valleys and scattered fertile land has, in a way, shaped the social and cultural geography of the community itself. 21. Hocking River's reroute saved a city. The city of Athens, home to Ohio University, was historically plagued by repeated floods from the meandering Hocking River. In a massive civil engineering project in the 1960s and 70s, the river was fundamentally straightened and moved away from the city center. The new, deeper and straighter channel significantly reduced the flood risk. The former sprawling floodplain was then opened up for safe, non-residential development, most notably for the expansion of the Ohio University campus you see today, a dramatic example of humans redesigning natural hydrology for safety and progress. 20. Serpent Mound, earthwork, and impact. The Great Serpent Mound is a masterpiece of indigenous earthwork, winding an immense 1,300 feet along a natural plateau above Brush Creek. Its location is geographically fascinating. The bedrock underlying the area shows clear evidence of the Serpent Mound impact structure, a massive ancient meteor impact that fractured and uplifted the bedrock. This uplifted, resistant ring of rock created the unusual, high and stable plateau that the ancient builders of the Adena culture chose for their colossal, beautiful, and enduring ceremonial structure. 19. Hopewell Ceremonial Earthworks, world recognition. Ohio is home to the Hopewell Ceremonial Earthworks, a complex series of geometric mounds and embankments, including the Newark Octagon and the Great Circle near Chillicothe. In 2023, these sites were formally recognized as a UNESCO World Heritage Site. The large, flat, stable glacial outwash plains and river terraces of the central Ohio region provided the perfect canvas for indigenous engineers to construct these immense forms. Their precise geometric shapes and complex lunar alignments tie the landscape, the sky, and ancient culture together in a profound expression of integrated geography. 18. Cleveland Shale, the cliffs that crumble. The geology of northeast Ohio is defined by the dark, easily erodible Devonian Cleveland Shale. This soft rock forms steep, crumbly slopes and cliffs in the region's many ravines and river valleys. The constant erosion of the shale, particularly when saturated with water, leads to frequent slumping and slides. This geological factor heavily influences urban planning, dictating where roads and bridges must be built, where utility lines can be safely buried, and where neighborhoods can be safely developed away from the unstable sliding slopes. 17. Put-in-Bay's Monument, limestone on limestone. At South Bass Island, the towering Perry's Victory and International Peace Memorial stands as a solemn geographic marker. The monument rises high over the sheltered Put-in-Bay Harbor, built directly on the limestone bedrock that forms the entire island chain. The very stone beneath your feet, the same Devonian limestone that was scraped and polished by the glaciers, is the same fundamental rock that provides the stability for the massive memorial and the harbor below, showcasing a clear continuity between the local geology and the human construction. 16. Little Miami, a river set aside. The Little Miami River, flowing through southwest Ohio, has been designated a National Scenic River. This protected status is a testament to the river's lucky geography. Its valley narrowly escaped the heavy channelization and damming that altered many neighboring rivers. Today, the river serves as a crucial natural corridor of preserved riparian forest, clear riffles, and exposed fossil-rich banks. It acts as a major refuge for wildlife and a popular recreation trail, demonstrating the value of a river system that was largely allowed to follow its natural, winding pre-glacial course. 15. Cincinnati's Seven Hills, a real geology. Cincinnati's famous moniker, the City of Seven Hills, is a description rooted firmly in real geology. The hills are actually a series of dissected bedrock ridges and elevated Pleistocene terraces, carved by the powerful Ohio River and shaped by glacial meltwater. The various neighborhoods of Cincinnati literally cling to these ancient benches and spurs, making spectacular, sweeping views an integral part of daily life. This rugged topography also introduces challenges, including landslide hazards and complex hillside zoning, for which the city is famous. 14. The Appalachian Glacial Line is a hard edge. One of Ohio's most fundamental geographical features is the boundary that marks the farthest reach of the last ice sheet. This line is a hard, diagonal edge dividing the state. To the northwest, you find the glaciated region, flat, fertile, and with straight, organized drainage patterns. To the southeast, you find the unglaciated Appalachian Plateau, rugged, heavily forested, dominated by thin, acidic soils and featuring chaotic dendritic stream patterns. This boundary line fundamentally explains agricultural patterns, forest cover, road layouts, and even settlement density across the state. 13. Indian Lake, remade waters. Indian Lake, another of Ohio's former canal reservoirs, is one of the state's largest inland bodies of water. Today, it hosts one of Ohio's largest inland beaches and is defined by its extreme shallowness and its exposure to wind fetch. The wind, blowing across the wide open surface, drives wave action that constantly molds its numerous small islands and shifts the fragile edges of its surrounding marshlands every season, making it a highly dynamic and geomorphologically active inland lake. 12. Alum Creek, Hoover, Caesar Creek, modern flood tools. Many of central and southwest Ohio's largest lakes, including Alum Creek, Hoover, and Caesar Creek, are not natural. They're modern, man-made U.S. Army Corps of Engineers, or USACE, flood control reservoirs. Built within pre-existing glacial or bedrock valleys, their primary function is to moderate peak flows of river systems during heavy rain events. They utilize the existing valley geography to pool water when necessary, serving a crucial flood mitigation role, while also doubling as popular recreation hubs layered onto old valley floors. 11. The Erie Snowbelt is a latitude, not a line. The legendary Erie Snowbelt that affects Ashtabula, Geauga and lake counties is a phenomenon that depends more on dynamic geography than fixed latitude. The amount of lake effect snow depends on a precise formula, the direction of the wind, the fetch, or the distance the wind blows over open, unfrozen water, and the local topography. This dynamic explains why the small town of Burton, elevated in the Cuyahoga Hills, can be buried under several feet of snow, while Cleveland's west side, just a few miles away, may only experience light precipitation. Wind and water shape the extreme weather. 10. Maumee Bay's wildlife comeback. Despite the ongoing challenges posed by nutrient runoff and algal blooms, the geography of Maumee Bay and the adjacent Ottawa National Wildlife Refuge is driving a spectacular environmental comeback. The extensive efforts in wetland restoration along the shore have revitalized this crucial geographic nexus point for migratory birds. This area, perfectly positioned on the western edge of Lake Erie, is now a magnet for bald eagles and a major stopover for waterfowl, demonstrating how careful management can leverage geography to write a powerful second act for local wildlife. 9. Ohio Caverns and Olentangy Indian Caverns. In the central Ohio limestone belts, water has carved a spectacular hidden geography of subterranean caves. Ohio Caverns, near West Liberty, is famous for its astonishing array of speleothems, cave formations that include stalactites and flowstones. Similarly, the Olentangy Indian Caverns showcase vast historical passageways. These karst windows provide a glimpse into the mostly buried world of dissolving limestone bedrock, a slow, continuous process where slightly acidic groundwater sculpts the underground landscape into art. 8. The Newark Earthworks, astronomy on the ground. The Octagon Earthworks in Newark, part of the Hopewell tradition, are a mind-blowing example of ancient geographical engineering. This massive enclosure was built with such precision that it maps the 18.6-year lunar standstill cycle. The vast, flat, and stable glacial outwash plains of the central Ohio region provided the perfect, stable canvas for the indigenous engineers to lay out a geometry that integrated the terrestrial landscape with celestial movements, demonstrating an astonishing level of astronomical and geographical knowledge. 7. The Portage Lakes, Ice Rim Legacy. Just south of Akron, the Portage Lakes are a defining feature of the local topography. These are classic kettle ponds and marshes, depressions left at the glacial margin when massive blocks of ice melted out. Today, they're stitched together as a state park, creating a complex geography of hidden coves, shallow canals, and lily-rimmed shores. They're a direct, continuous legacy of the last ice age, occupying the melt-out basins left right at the southernmost edge of the continental ice sheet. 6. The Scioto and Olentangy confluence built a capital. The location of the state capital, Columbus, was a deliberate geographic choice. It rose at the junction of the Scioto and Olentangy rivers on a broad, level outwash terrace, a flat plain created by glacial meltwater. This terrace was high enough to generally avoid the highest flood stages and flat enough to accommodate a massive, easily gridded street plan for the capital city. Today, the rivers and their confluence continue to sculpt the city, providing vital green corridors and parks that define neighborhoods and recreation paths. 5. The Sandusky Bay Alvars, thin-soiled wonders. On certain shorelines of Lake Erie, particularly near Sandusky Bay, a rare and fragile habitat called alvar forms. This geography is characterized by expanses of bare limestone pavement with only paper-thin, scattered patches of soil. This incredibly harsh, dry, and exposed environment hosts a unique community of rare plants, lichens, and shorebirds. From a distance, the bedrock looks like a tilted, ancient parking lot, but it's a globally rare ecosystem driven by its unique geology and climate. 4. Ohio's two climate personalities. Ohio straddles two distinct climate zones. Northern and central Ohio fall firmly within the humid continental zone, characterized by cold winters, often significant lake effect snow, and sharp seasonal changes. However, the far south near the Ohio River subtly shifts toward a humid subtropical tendency, with significantly longer growing seasons, hotter summers, and milder average winter temperatures. The Ohio River Valley is the unofficial geographic line that marks this important climatic shift in the state. 3. The Great Circle of Rivers to the Gulf. The water that falls south of the Akron Continental Divide embarks on one of the longest geographic journeys in North America, the Great Circle to the Gulf of Mexico. Every drop follows a path. Scioto River, Ohio River, Mississippi River, Gulf of Mexico. Water to the north flows Cuyahoga Maumee River, Lake Erie, St. Lawrence River, Atlantic Ocean. One state, one line, and two entirely different oceanic pathways, a clear hydrologic divide for the continent. 2. Serpent Mound isn't alone. Impact Ohio. Ohio is host to a surprising number of ancient impact structures, including the confirmed Serpent Mounds structure and several others. These impact events fractured and uplifted the bedrock in localized areas. This fractured bedrock creates distinct, measurable differences in the local groundwater flow, surface topography, and even the mineral composition of the soils. These often unseen geographic structures can influence where roads are difficult to build and where unique springs or aquifers might be found. 1. Ohio is where three Americas meet. Ohio's geography is a spectacular tapestry woven from the collision of three great American landscapes. The flattened, fertile glaciated Midwest meets the rugged, forested Appalachian Plateau and the enormous inland sea of the Great Lakes. This colossal geographical convergence is why Ohio can put oak savanna, island cliffs, Appalachian hollows, and dense industrial river valleys all within the drive of a single morning, making it one of the most geologically and topographically diverse states in the entire country. From buried Ice Age rivers and lunar-aligned earthworks to salt mines beneath a Great Lake and deep canyons carved in sandstone, Ohio is a masterclass in how ice, water, ancient rock, and human ingenuity continually conspire to reshape a place. The story of Ohio's geography is never finished. Which Ohio fact made you go, "No way"? Tell us in the comments. Subscribe to Around the World for more geography that actually explains the world around you.